Good morning, everyone. My name is Janita Millman from eWater. Welcome to our webcast this morning. The title of the webcast today is Building a Calibrated Rainfall Runoff Model with eWater Source. And we're going to talk about using eWater Source to model the rainfall runoff process in your catchments. With me, I also have Shannon, who is helping me with the technical side of this presentation. If you have any questions during the webcast, please interrupt us. We won't be taking any verbal questions, but ask that you type your questions into the GoWebinar panel where it says questions. We will also have a Q&A session at the end of the presentation. So, how do we deal with catchments in eWater Source? Well, consider a typical catchment. Rainfall falls on the catchment. This rainfall then moves through the system where it is captured by land cover, or it might be infiltrating into the soil. Some of it goes into groundwater and returns. Some of this rainfall eventually makes it to the river, where it could be used again by another water user for irrigation, or it can be held back in a storage. Now, Source provides a framework that you can use to represent all of these processes inside your modeling system. Source does this by giving you the option of either a schematic scenario or a geographic scenario. The schematic scenario is generally used to represent the water management elements and used to make operational decisions. The geographic scenario, on the other hand, is designed around catchments. And this is what we will be speaking about this morning, and how we apply our rainfall runoff models to simulate flow in these catchments. So the scenarios are built up of nodes, and the connectivity between these nodes is done with links. If you have a look in the middle of the screen in front of you, you will see some of the nodes that are available for you to use in Source. Typically, a geographic scenario or a catchment scenario starts off with confluence nodes, joining the links in the between catchments. When you start building a catchment scenario in Source, you derive catchments. You will then add functional units to these catchments. Functional units are areas of similar runoff response. Source then provides a number of rainfall runoff models that can be added to the catchments and functional units and applied. And we then finally, we will add our climate variables which drive the whole process. There are two types of data that are used to build a catchment scenario. There is spatial data and there is time series data. The spatial data consists of catchments, raster, which will be catchments that you have derived beforehand and can import into Source, or you can input a digital elevation model into Source and use that to derive your catchments. You can also add various gauges or storages at points that are critical in your catchments, and then also add your own outlets to the catchments that you have derived. Finally, the functional units, often comprised of land cover or combined with soils and slopes, will be added to your catchment scenario. Time series data in Source. We have climate inputs, such as rainfall and the evaporation, as well as observed flow. An observed flow is typically used to calibrate your final modeled or simulated flow. Source also has modeled outputs, which are output as time series, and these are called recorders in Source. There are a number of rainfall runoff models available to be used in Source, and I will demonstrate one of these later. In summary, Here are some of the steps that you will go through when you are designing your catchments scenario in eWater Source. You will create a new project and a geographic scenario. You will define your catchments that you need for your model, taking into consideration the size and number of catchments that you want to be using, as well as where the outlets are and any other critical features in your catchment. You will add your functional units, choose a rainfall runoff model, add the climate data, parameterize the rainfall runoff model, set the elements for recording for output, run the model, examine the outputs, and then finally calibrate and validate your model. Looking very briefly at calibration of the model, model calibration is the process of optimizing or systematically adjusting model parameter values to get a set of parameters which provides the best estimate of the observed stream flow. And when you configure your model for calibration in Source, you have the ability to calibrate on either a single point, a gauge, or a reach. You can then choose from a number of objective functions, load the observed data, select a warm-up period for your model, select a calibration period, define the parameters that will be optimized, as well as perhaps any catchments or functional units that you only want to parameterize on, and finally select an optimization function. I will touch briefly on the objective functions in Source. We currently, in the version that I will be training on in October, we have 4 objective functions. However, this is a growing list. As mentioned, we will be presenting a course on building your own rainfall runoff model with eWater Source in Sydney on the 27th and 28th of October. If you want any more information, or if you are interested in registering for this course, you can go to www.sourcetraining.ewater.org.au. Now let us have a look at how you would actually implement building the model in Source. First, one chooses to build a geographic scenario. At any point on those first 2 screens, you are able to input your own descriptions and your own scenario name. For this demonstration, I will use a digital elevation model to generate catchments for Source. The resolution of screens and the number and size of streams and the number and size of catchments that you have can be controlled using the minimum sub-catchment area. As I make that area larger, there are fewer streams. We can load nodes to illustrate important features, such as maybe a flow gauge site or a storage in the catchment that one wants to have catchments delineated at. I'm going to choose quite a large sub-catchment area so that we only have a few catchments just for demonstration purposes. As I add my outlets, yes, I will apply the new catchment size and add outlets. There are 3 catchments, 2 representing the flow site and the storage, and then 1 small catchment at the end representing the outlet. After loading the catchments, the functional units can get loaded. I have a shapefile from which I will load the functional units. For the simplicity, I have functional units that only consist of land cover. Source will automatically calculate the area of each functional unit inside the subcatchment if I use a shapefile. Source creates the model. Can show the node names, which shows that this is the node that represents my dam or storage, and this node over here represents the flow site. With the catchments loaded and functional units assigned, the next step is to load the rainfall runoff model. There are several rainfall runoff models available. We will use GR4J for this demonstration. And you might have noticed that as soon as I chose the rainfall runoff model, the parameters of that model became visible. I can copy and paste my chosen rainfall runoff model to all the catchments and functional units, loading climatic data, comes from a file that is already existing in Source. CSV is a very common format to use to input data into Source. It is important to select the units that the input data is in. Rainfall data imported in a similar manner. Again, I will select the units. Make my time series active, and this is now applied to the rainfall runoff model. Similarly, I can copy and paste those time series into all my cells. Something to mention at this stage is that one might want to model rice, for example, in a different way to how you model forest. So if you have a particular model that you would like to use on that functional unit, one can choose a different model. It is also possible in Source to write your own model using plugins. And in later versions of Source, we have introduced the functionality to be able to design your own rainfall runoff model just by inputting functions. Once that is all set up, the final step before running the model is to choose one's recorded output. So in the top part of the screen, you will see the features that are within the model, and below that, the recorders that can be used to measure the flow or any other process that you have in the model. So I'm going to start by measuring my flow at the downstream flow site. And I will measure the downstream flow. Configure sets the dates that are used in the model. And you might notice that evaporation goes from 2006 to 2010, while rainfall goes from 1992 until 2008. Source has automatically selected the overlapping period between these two time series. I see we have a question. How do you get later versions of Source with the additional functionality? Well, later versions of Source are available to people who have a support and maintenance agreement and can therefore have access to beta releases of the software. I have configured the model. When I click on the Run button, the model runs. and my recorded output appears at the bottom of the screen. So that is the first recorded output for your model. We can compare different recorded outputs. So I can now, if I want to know what is the recorded output downstream of my storage, and then I could compare those to each other to see the change in flow as one moves down the system. Downstream flow in the storage. It is possible in source to drag these two time series on top of each other and be able to do a comparison in that manner. You can also view your time series, your graphed time series, in a table. This table can be exported to CSV format, or it can be automatically opened in Excel. There are also some statistics available for examining the data more closely. Aha, some more questions. Where do you enter rainfall runoff model parameters? To enter rainfall runoff model parameters, one uses the same screen as you used to choose the rainfall runoff model. So it's edit rainfall runoff models, and the rainfall runoff parameters can be entered in the cells alongside your chosen rainfall runoff model. Another question. Will this be different for different catchments? It can be different for different catchments if you choose it to be different. So you can choose. So I have subcatchment 1 and subcatchment 2 and subcatchment 3. I can enter different values in any of these cells for those subcatchments. Similarly, I could enter different values for different functional units also. Do we have any more questions at the moment? Okay. Well, I think that is as far as I'm going to go with this demonstration at the moment. So please, if there are any more questions, feel free to ask us at this moment. Otherwise, I would just like to point out to you again that there will be a course being presented in Sydney, which will explain in a little more detail to you about building a calibrated rainfall runoff model with eWater source. Some questions, thank you. Can I enter observed ET instead than PET? Yes, you can. Next question, can you tell us a bit about data requirements and preparation for input into source? Yes, as I mentioned, that we have two broad data types that are inputted into source. You have spatial data and time series data. The time series data typically is entered as a .csv file, which is comma-separated values. You will have a date in the first column, and that date will represent the time step of the model, typically daily. And then the second column of the time series will have the values of your data that you are entering, and these values, you could have several columns. So it is possible to put the ET and the rainfall data all in the same time series, and then just choose which column it is that you're wanting to import. Secondly, in terms of the spatial data, a critical thing to remember about importing a digital elevation model for building your own catchments is to pitfill that digital elevation model before you import it into source. Next question, can you show us where you go to optimize the parameters? Yes. The calibration wizard for source can be accessed on the top, from the top menu bar, from the top toolbar of the software, and it is called Flow Calibration Analysis. Next question, can you create spatial data within source or only import from pre-processed data in a GIS program? It is, yeah, you can, in source, save out the catchments that have been generated, but those will be based on pre-processed data that you have imported into source. So the answer here, I think, is that you have to prepare your data in a GIS and then import it into source. Is there anything more? Yes. Next question. Can you show us adding nodes manually? I will start a new window in source. Nodes are loaded from an existing shapefile, but you can add outlets manually in source. So I can choose an outlet at any point along that river system, and it will produce a set of catchments. Next question, can you tell us about any interesting case studies which have used this functionality in source? Well, for myself, one of the more interesting case studies that I've encountered is that Queensland government has actually built a system for modeling the sediment runoff into the Great Barrier Reef using source and a plugin that they have developed to do this. Question, can you output the catchment boundaries and nodes that are generated? You can save out the subcatchments as well as the node locations by right-clicking inside the window where the catchment generation takes place. To what format? Subcatchments are saved out as shapefiles. Node locations can also be saved out as shapefiles. Can you tell us a bit about water quality, either existing or future developments? I have not included water quality in the presentation this morning, and we also will not be including water quality in the training that I'm going to be presenting in October in Sydney. However, there is provision made for constituent modeling inside source, and we will be having a course specifically to speak about water quality in source in February next year. At the moment, there is a lot happening in the water quality world in source, and we are proposing to extend this functionality to include the Qual2E algorithms that are available and commonly used to model water quality in modeling programs. Another question, can we analyze the effects of land use change in the stream flow, on the stream flow changing the location and size of HRUs and respective ET? Yes, you can change your ET at any time inside the model. I will edit rainfall runoff models in the same place where you originally added the rainfall and ET. One can also change these time series and add new data at any stage. Similarly, you can change functional unit areas manually. The only proviso to that is that at all times, these functional unit areas per catchment must add up to 100% of the catchment. Another question, what do you see as the benefits of the rainfall runoff modeling in SOURCE versus other hydrological models? Well, I think the greatest benefit to myself of using rainfall runoff models inside SOURCE is that one actually has an integrated platform in which you are modeling. And something that I haven't shown you yet, because we have been speaking specifically about looking at catchments, but I did mention in the earlier presentation that SOURCE also has a schematic view. And something you can do with your catchments is have a look at those catchments in the schematic view also. So what I'm showing you here is merely a schematic view of the same catchments that you saw in the geographic window. And these catchments, from this view, one can actually start accessing a lot of the functionality that is only available to schematic views, such as adding water users. Another question, how do you calibrate the model? To calibrate the model, you will use the Flow Calibration Analysis Wizard. And I'm not going to go into a lot of detail about calibration today, but I am going to suggest that if anybody is really interested, you can contact us, or even better, come along to the training course at the end of October, and where we will spend a lot more time actually speaking about calibration in SOURCE. What should be the resolution of the DEM? The resolution that you choose for your digital elevation model depends on the size of the catchments and the resolution of the streams that you're wanting to generate. When will the Qual2E functionality be made available? I would envision that that functionality will be available in the next few months and will be coming out in one of the later beta versions. Is the runoff model linked to sediment module and output in SOURCE? Yes, it can be linked to a sediment module and output in SOURCE. Right, more questions. What is the maximum size DEM SOURCE can handle in terms of nodes or megabytes? SOURCE can handle quite a large DEM, and you could handle something up to about 3/4 of a gigabyte in size. A bit more on the land use change. I have a question. What you showed indicates only the change in percentage of the units. Does the location of the units affect the results? No, we do not take the location of the units inside the catchment into consideration. We use the size of the units to model the rainfall, the runoff coming from each functional unit. One can put some there is a way to, oh no, sorry, I was thinking of something that is one of the later versions of SOURCE. So no, the location of the units at this stage does not affect the results, but location can be taken into account in the way that you create your functional units. So you might want to use something like slope as an extra factor in the functional units to actually represent the location of that functional unit inside the topography of your catchment, and then have a different parameter set for functional units that are on steep slopes versus those that are on flatter slopes. Is there any snowmelt model? There is not currently specifically a snowmelt model for source, but you could build one and add it as a plugin if required. So is it a catchment averaged? It is a functional unit averaged, is the question that I've just had. And then another, do you have SRM model in source? No, we do not have the SRM model in source. But again, this is if you have any particular models that you would like to see in source, this could be done using a plugin. Another question has just come in. Is there a bank of plugins to be used by users? There is a bank of plugins that users can use, and they will be downloaded at the same time as you download your source version. So Tools Plugin Manager will take you, I will need to open a new source version to be able to show you what those plugins are. But you can have a look at the plugins from your own source window before you've created a model on a fresh open source project. You go to Tools, Plugin Manager, and you will be able to then browse to the folder which contains a list of plugins. There is also a list of community plugins that can be downloaded together with the source download. What does the ordering drop-down do? The ordering drop-down is typically used in a schematic model and is used to simulate ordering for water throughout the system. The next question, can you please explain the evaporation rainfall data files? If it is a CSV, is only point data, or is it possible to use gridded data if your catchments cover large areas? Yes, thank you for that question. Yes, it is possible to use gridded data. And we have a tool called the Climate Data Import tool, which can be used to import rasters of data. I have a question from Pakistan. We have snow modeling, and it will be good to have a snow model in source. Thank you for that. Yes, I agree. It will be good to have a snow model in source. Does source accept a digital elevation model in negative numbers? Better to use integer or floating numbers. How about the projection? Yes, the digital elevation model, I will start with the last part of that question, which is how about the projection? Source considers the digital elevation model that you import to be in whatever coordinate space you have imported it. However, because that digital elevation model is being used to calculate catchments, and those catchments, well, the parameter that we're interested in from those catchments is the catchment area. So that digital elevation model has to be projected. Okay. When you add water user nodes in the schematic view, do these nodes appear in the geographic view? Yes, but as we've just spoken about projections, those water user nodes need to have eastings and northings assigned to them that are in the same projection as the input data, digital elevation or catchment data, and then yes, they will appear in the geographic view. How are the crop parameters used? There are a number of cropping models that are available in source. This is starting to move a bit more into the schematic world now than just the catchments world. But there are a number of crop models that are available in source, and if we have a look, the node palette, I can show you. Once I edit my water user to be an irrigator, I can assign various crop models to that water user. Next question, can you show adding nodes in the schematic and viewing them in geographic view? I can do that, but I'm going to hesitate to do it because of time constraints in this session. And I would suggest that anybody who would like to know more about doing that and see a demonstration, please contact me later, and then we can actually talk about doing that. Or even better, come along to the course, and I can show you how to do that. If you're not able to come along to the course, I'd really be very, very happy to speak to you about how to add your nodes in the geographic view at any time. How does source decide on the sub-catchment breakdown? The sub-catchment breakdown is according to the size of catchments that the catchment size that you choose when you are setting up your first model. There is, in the input screen for the digital elevation model, there is a minimum sub-catchment area that can be input. Next model, why have you used GR4J model? Is there any specific reason? I'm afraid I'm going to have to be very honest with you on this. The reason why I chose the GR4J model today is because it only has 4 parameters and is a quick model to run. So for demonstration purposes and for training purposes, it is a good model to use. However, the GR4J model has shown that it works very well in varied types of catchments, and we have actually applied it here at eWater in a number of different types of catchments and runoff and rainfall regimes. Another question, is there anything in source regarding the climate change impact assessment? You can use source to simulate climate change impacts by producing different scenarios with different rainfall inputs. There is also in source the stochastic analysis tool, which can be used to generate various rainfall scenarios. Is this standard source software free for us? If not, how much is it? Thank you. Well, I'm going to suggest that if you would like to purchase a software package, you could speak to Meryl McCarrow by accessing our eWater website, ewater.org.au. However, the standard source software is free, and there is a public version available from our website, and this version that I have used to demonstrate to you today has used only freely accessible features. Has any kind of QA been undertaken on the available plugins? There has been QA on the plugins that are available. However, the eWater does not support or in any way do QA on the plugins that you might import from the community plugins website. Has someone from... okay. Next question. What rainfall runoff models are suitable for urban catchments? Edit rainfall runoff models. Source has an urban product called Music, which specifically focuses, not Source, I'm sorry, eWater has an urban product called Music, which specifically focuses on stormwater in urban areas. However, if you want to use the catchments model for larger areas, we have the CERM model, which is an urban rainfall runoff model. Next question, what is the minimum time series of precipitation and PET would you recommend to calibrate the model? I would recommend that you go for an absolute minimum of 10 years, but it does depend on the data you have available. There is an advanced water system planning course coming up in November. Yes, there is an advanced water system planning course coming up in November. Thank you for whoever brought that to my notice. And So questions on adding water users and what types of crop models are available, as well as questions on ordering, will actually be addressed in that advanced water user planning course. Rainfall, what can source be used as a forecasting model for long as well as short-term forecasting? Again, we're moving into the water planning part of source. But yes, it can be. Do source and music products have the same results if used for the same catchment? Yes, they have been tested. The CERM model is also in part of music, and we have tested that they produce the same results. Can you use source for the design rainfall events rather than long-term flow calculations? Yes, you can. Does anybody have anything more that they... Yes, is SEDNet still available or fully integrated into source? SEDNet is available as a community plugin and is not actually totally supported by source for that reason, but it is still being used, and dynamic SEDNet, which is a daily version of SEDNet, is being used extensively by the Queensland government to model the sedimentation of the Great Barrier Reef. And if you're interested in that plugin, I would suggest that you contact them. Is setting the time step set by input data? Yes, setting the time step is done by the input data. And is there a stochastic method of changing daily data into hourly data? No, at the moment source will not automatically change your data for you, and it is set by the time series that you input. How do design flood events compare with other hydrology models? I see that there's a lot of modeling questions starting to come through, and I'm going to suggest that for these kind of questions that you have a look at our best practice guidelines that are on the eWater website, as well as the scientific reference guide, which is also on the eWater website. Do you see source replacing music in the future? No, not at all. Can source run on a sub-daily basis? Source can run according to the model that is being used. So if one is using a model that is relevant for sub-daily running, then yes, source can run on a sub-daily basis. What about the glacial melt modeling? I think, as I mentioned before, there's currently not a snowmelt model in source. We are considering looking at various snowmelt models, but there is not currently a snowmelt model or glacial melt model in source at all. How can you apply the model to other catchments different to the one you calibrated the model on? Would you only apply the same parameters and assume it works? There is a lot of theory behind applying models on neighboring or other catchments. Applying calibrated parameters. And you would have to do that cautiously, but yes, often one can apply the same parameters to other catchments that are similar to the one that you have run your calibration on. Can source be used as a flood forecasting model? Source is not a hydrodynamic model. Here's another question. How does source decide on the sub-catchment breakdown? I think somebody has just asked me to go through that one again. When you start off adding in the sub-catchments, source provides one with an opportunity to choose the minimum sub-catchment area, and that is what actually sets the sub-catchment breakdown. So I think I'm going to have to wrap it up there. We have one final question. Is it just from the outlet node, locations, and catchment size that you set? Yes, it is from the catchment size that you set, but not only from the outlet nodes, but also from any other nodes that you add that will be inside your catchment area. One last question before I wrap up. I see there's nothing more coming through. Thank you to everybody who came along to the presentation this morning. And before I wrap up, I believe there is one more question that is coming through. There is one more question coming through, but before I take that final question, I would just like to point out to you that we will be having a course, Building a Calibrated Rainfall Runoff Model with eWater Source, in Sydney on the 27th and 28th of October. And if you would like to register for this course, please contact us at www.sourcetraining.ewater.org.au. Aha, here we are. Here is a final question that somebody has put through, and I thank you for this information. Cyro has developed a prototype snowmelt plugin, thank you very much, which will be added in the community space for Source. So thank you for the person who has given me that information. And the snowmelt plugin is attached to the GR4J rainfall runoff model, which is the model that we have just been discussing today. Thank you everybody who joined us today. I invite you to please contact us with any further questions that you might have, and we will be very happy to answer those for you.